Distributed ledger technology. In distributed database management system, data is not stored centrally on a server. Rather, it is distributed over few servers, PCs or cloud. There are many examples such as Hadoop, NoSQL, peer network node data stores, distributed SQL, etc. These are the architectures widely used by likes of Facebook, Google, Amazon. After launch of Bitcoin, distributed technology came in limelight, though it was discussed in some research papers during 1990s. People may say that distributed ledger technology is an extension of distributed database management system. Distributed ledger technology is a transactional type of distributed database management system. In DLT, it deploys timestamping, which is used for a while in many distributed database management systems. Timestamp based concurrency ordering control algorithm ensures time-linked sequencing of transactions. It endorses immutability to transactions, which is already used by Google HDFS, etc. It incorporates consensus mechanism for validation of transactions in the network. The same is used outside DLT space in Raft and Paxos. However, DLT has a leverage of cryptography over distributed database management system. It's true decentralized read-write network that doesn't have parallels. Along with that, ability of DLT to secure transactions using host of protocols sets it apart from all the conventional ones. Smart contracts are integral part of DLT. They add capabilities of building business logic and business processes, which can facilitate automation of transactions based on predefined conditions. These technologies encapsulated in DLT forge trust among not so trusted users. There are two users in DLT: transactional users and miners or blockchain operators, or you can say blockchain generators. These users operate DLT through processes in following sequence: network discovery, transaction creation, including asset creation and developing smart contract, block generation and submission, which is nothing but mining and consensus process, and finally blockchain validation. Broadly, DLT data model constitutes three components: transaction, block and block header. Together they capture the state of ledger. Block and block header are standard and essential to every blockchain platform. Block contains transactions. The block's metadata is kept in the block header, consisting of hash of previous block, Merkle tree, and nonce. Language of transaction consists of methodology for registering ledger services, testing the deployed ledgers, reference implementation for storing on-chain configuration settings, handling on-chain permissions for users, and identify management as a whole. Every other blockchain DLT uses different protocol for consensus management. That is proof of work, proof of elapsed time, proof of stake, etc. The selection is based on business applications.